Hi everyone! In this part I want to give an application of derivative, which is curve sketching. If you have some simple functions, of course it's not so difficult to draw their graphs, but if you have a rational function or if you have a more complicated function, it's not always so easy to have their graphs. We must know some techniques. So the first concept which is related with these techniques is the critical point. We say that x equals c is a critical point of a function, let's say f of x, if f of c exists and if either of the following are true. So if either f prime of c is equal to 0 or f prime of c does not exist. Okay, so if derivative of a function at a point is equal to 0 or does not exist, we say that this point may be a critical point. Why do I say maybe? If this point is in the domain of the function, then it is critical point. If this point is not in the domain of the function, of course it cannot be a critical point. This is a crucial remark. So let's solve some problems. Determine all the critical points for the given function f of x. To find the critical points, of course, we must have derivative of f. Derivative of this function, to find derivative of this, I advise you to first substitute the function. Let's say this is equal to 2 times x to the power 5 over 3 minus x to the power 2 over 3. Okay, it is a simplified version of the original function. I think it's more easy to take derivative of this version. Derivative of f is equal to, using the properties of derivative, you have 10 over 3 reduce the power 1, then you have x to the power, if you reduce the power 1, 2 over 3, okay, minus, again using the properties of derivative, you have 2 over 3 as a coefficient of x, and you have x to the power 1 over 3, okay. It is derivative of f. If you simplify this expression, you have a rational function, 10x minus 2 over 3x to the power 1 over 3. Okay, if you simplify, you have this one. So what can we say about this derivative? As you see, at the point 1 over 5, it becomes 0, right? When x is 1 over 5, then derivative becomes 0, and as you see, since we have a rational function, the point 0 makes denominator undefined, right? So f of 0 does not exist. So what do we say? 1 over 5 and the point 0 are two critical points, right? 0 and 1 over 5 are two critical points for this function. Okay, and they are in the domain, so no problem. Since you have a polynomial function, polynomial functions are continuous everywhere. Their domain is the whole real line, so these 2 points are in the domain, so they are critical points for this function. Let's look at the second function, 10x times exponential function. To find, let's say this is g, this is the function g. So derivative of g is equal to, you have multiplication of two functions. If you use the properties of derivative, you can easily obtain its derivative. Okay, plus 10x times minus 2x, derivative of first component times second, okay, and derivative of second component times first function. It is the first function. Now I am taking derivative of second one. E to the power 3 minus x squared is the function, okay. So let's continue to simplify this expression. G prime is equal to, I simplify the function, 10 e to the power 3 minus, I do not change this part, x squared minus 20 x squared times at the exponential part. I still can substitute this function. I can take the parentheses of 10 exponential function 3 minus x squared, and we have 1 minus 2x squared, right? So as you see, this derivative of this function is equal to 0 when x is equal to plus minus 1 over square root of 2, right? If you give 1 over square root 2 to x, then g prime becomes 0. So we have two critical points, either 1 over 2 or minus 1, either 1 over square root of 2 or minus 1 over square root of 2. Two critical points. So take the derivative and check at which points the derivative becomes 0, at which points derivative becomes undefined. Okay, so if this domain, if these points are in the domain, then you say they are critical points. The second important concept for curve sketching is increasing decreasing functions. Let's see the formal definition. A function f is increasing on an open interval AB if f of x2 is greater than f of x1 whenever x2 is greater than x1. Let's look at these 2 points, x1 and x2 are given, and f of x1 and f of x2 are also given, right? As you see, x2 is greater than x1 and f of x2 is greater than f of x1, right? In this case, the function f is increasing on this interval. It is the first definition. Let's look at the definition of decreasing. A function is decreasing if f of x1 in this case is greater than f of x2 whenever x2 is again greater than x1. Let's choose 2 points, x2 and x3 now. Let's compare them. On this interval, as you see, x3 is greater than x2, but x3 is greater than x2, but f of x3 is smaller than f of x2. See? F of x3 is here. This is smaller than f of x2. So in this case, the function is decreasing on this interval. Okay? It is the formal definition of increasing and decreasing function. I have another definition which is monotonic. A function that is increasing or decreasing on an interval is called monotonic function. So, if a function is increasing or decreasing, it is called monotonic. If it's monotonic, then it's either increasing or decreasing on a given interval. We have a test, derivative test for monotonic functions. Let's see what do we have in this test. Suppose that we have a continuous function on a closed interval AB and differentiable on an open interval AB if f prime is positive, okay, at each point of x in the given interval, okay, if you have this, then f, the function itself, is increasing, okay. Of course, on the given interval, closed interval. If f prime, if derivative is negative at each x on the given interval ab, then in this case the function is decreasing on the given interval, closed interval ab. Okay, it's a very useful test. So in order to decide whether the given function is increasing or decreasing on the given interval, we will use this test. We will check, we will find the first derivative and check, is it positive on the given interval or negative. So it is all is a very useful test. Now let's look at an example. We have a polynomial. So the question is, determine all intervals where the following function is increasing or decreasing. Let me first find the derivative of that function. Of course, it's very easy to find derivative. I directly write a substituted version of this derivative, okay? You can take the parentheses of minus 5x squared times x minus 4 times x plus 2. So when you make it equal to 0, then you see that you have three critical points, right? The first one is 0, the second one from here is 4, and the third one from here is minus 2. So at these critical points, f prime becomes 0, right? So it is the first step. The first step is to find the critical points. Now let's have a real axis. Let's say this is a real axis. Let's denote these 3 points. Let's say this is minus 2, this is O, and this is 4. Okay. Now I want to decide the behavior of the function on these intervals. I have 3 intervals, right? From O to 4. Okay, let's look at from minus infinity to minus 2. What do I have? I should have a test point. Let's pick a test point. Let's say minus 3, right? Let's look at the value of minus 3 in f prime. If you calculate, you will see that you have a negative number. The number itself is not important. The important test is negativity or positivity of f prime at this point. Since f prime at this point is negative, it means f prime is negative for each points on this yellow line, on this yellow interval. So from minus infinity to minus 2, the function is decreasing using the first derivative test for increasing, decreasing, let's say for monotonic functions. So the function is increasing, right? I should have another test on this interval. Let's say minus 1. If you check minus 1, you see that you have a positive number. By first derivative test for monotonic function, since f prime is positive, it means the function is increasing on this interval. And let's pick another number for the interval of 4. F prime of, let's say, 1. If you check this point on f prime, you will see that you have a positive number. That is, f prime is positive on this interval. It means the function is increasing on the interval of 4. What about the interval 4 to infinity? Okay, we choose another point, let's say f prime of 5 from this interval, and if you calculate, you see that you have a negative number. So f prime is negative. This is why the function is decreasing from 4 to infinity.